Welcome back, viewers, to the last segment of the third lecture. I am writing down the rules of good practice for one of the key features of Olog called types. The first rule is to begin with the word A or N for the label of the box, that is the type. Second rule is to refer to the distinction made and recognizable by the Olog's author. For example, for the second rule, we give an example. An automobile, which is a type, does not represent anything that can be eaten. That can be eaten. Right? An orange will not belong to the extension of an automobile, the extension of the type, the extension of the type, an automobile. Let me explain a little more. The extension of an automobile is the set of all automobiles, and an orange does not belong to that set. So as soon as we see an automobile, this type, we recognize that an orange does not belong to the extension of this type. Okay? Alright. The third rule, refer to a distinction. A distinction means a type. Refer to a distinction for which instances can be documented. What does it mean? For example, let me get back to figure 4, meaning there were two examples of types. Okay, one of the examples of types was this: triple P, A, J, where P was a paper, A is an author of B, and J is the journal where P was published. Okay. So this was a type, and for this example, we see that the triple P, A, J of the paper, author, and journal. Okay. So considering the triple PAJ that refers to the paper, author, and journal, will only be documented by the author, will only be documented by the author. Here, this author means the creator of the Olog, not this author. Not to confuse with this author. It means he's the author of the Olog. Okay, it's not, should not be confused with this author. All right. So this will be documented by the author, creator of the Olog, as an instance of meaning that the author, the creator of the Olog, is recording the data, the triples, whenever he comes across a triple satisfying the following properties, he immediately records it, okay, as an instance. So, the author will be documented by the author as an instance if A wrote the paper P if A wrote the paper P and P was published in J. Okay, so the creator of this Olog will document this triple P, A, J. Once he finds out that P is a paper written by the author A and the paper got published in journal J. It's only then the author of the Olog will document this triple as an instance of the time that we are considering, the time here that we have written. Okay, so third point is complete. Now there is a fourth rule that I am writing down. What is the fourth rule? The fourth rule suggests that one should not end in a punctuation mark. That I mistakenly did several times while drawing these boxes and putting down the label of the boxes. Okay, meaning that you should not put a punctuation mark inside the box, something like a man, and a man M, and a woman W. You don't end this statement with a full stop. No punctuation is allowed. The fifth rule: declare all variables in a compound structure. in a compound structure that we have already discussed in fair detail. Compound structure. Already discussed. Okay. So these are the rules of good practice for one of the key features of the Olog called types. Now, there is another feature of Olog called aspects. Let us move on to the discussion of aspects. Aspects. Aspect of a thing. Aspect of a thing is a way of viewing it. Is a way of viewing it. Strictly speaking, aspect is a morphism from one type to another type. Let me give you an example. Okay, so before giving you an example, I need you to understand the category theoretic feature of an Olog, meaning that for precision, we see that types are objects of some abstract category, of some abstract category called Olog. And the morphisms between the objects and the morphisms between the objects are aspects. Okay? So recall the Olog that we had discussed earlier, where we had various boxes connected with various arrows here. So these were types, and these arrows were aspects. Okay? So as a category, these boxes are objects and the arrows are precisely morphisms. So you can think of the aspects as morphisms and these types as objects of the category Olog. Okay? So I give you an example. Suppose a woman is a person. So we are given this Olog where a woman is a type, a person is another type, and they are talking to each other by means of this aspect is. So we should read it as aspect of a woman is that she is a person. Okay? So in the diagram above, the arrow labeled with is, this one, is a morphism from the object, a woman, to the object, a person. These are types of the Olog which are in the terms of category. They are objects of the category Olog, and the aspect is precisely the morphism between them. Okay? Now there is an important feature of aspect that we need to understand. There is it. Aspect upholds a functional relation. An important feature. Aspect upholds a functional relationship between types. Okay. But I told you earlier not to confuse a woman with the set of women, okay? And not to confuse the type, a person, with the set of all persons. They are different. They are distinct notions. So how does this aspect is reflects? How does it reflect a functional behavior? That's a question. That's an important question to address. So, in order to answer or address this important feature, we need a functor called instance functor. Okay. So, in order to understand it a little more concretely, we need the idea of instance functor. Okay, so in the first lecture, we defined what it means by a functor. We defined the idea of we defined functor between two categories. Now, here we'll have a real-life example of a function, which is called an instance functor. So here goes a definition. So we'll provide a partial definition here, because to have the complete definition, we need another feature of an Olog called facts. So let me give you the partial definition, because we need this definition, a partial definition, to delve more into the features of aspects. Okay? So here is the definition. Partial. It's relative to its definition for Olog as a category. Okay. Olog is a category C where objects are types, type being a box is labeled by a text, is labeled by a text that characterizes the type that we use here. Okay. Morphisms between these objects are precisely aspects. Objects are aspects. Okay. Okay. So instance functor, as we all know that a functor is it goes from one category to another category. Here, the instance functor is a functor. Functor is a functor from the abstract category of Olog to the category of set. Okay. That is, it consists of a set Ix, a set Ix for each object, of course, which is the type of the category C. X in C. What does it mean? It means that X is a type in this abstract category C, whereas while the thing Ix is an object in this category set, and the objects of the category set are precisely sets. So Ix is a set. Okay. The second point is about morphisms between objects or types. A function if from Ix to Iy for each arrow f from x to y in C. Correct? So what did we have initially in the category C? In the category C, we had two types connected by an aspect f. Okay? We had in C these two types connected by an aspect f. All right. Whereas by means of a functor I moved everything to the category of set, where Ix is a set now, Iy is also a set, and If is a function. So by functional behavior or functional properties of the aspect, we mean that If has to satisfy all the properties of the function. Okay? So there is an additional component of this definition which is related to facts that we have not discussed yet. So I postpone the remaining part of this definition until we have the concept of facts. Okay? So now, with the help of this notion of instance functor, one immediately sees what it means by aspects of holding a functional relationship between types. Okay? As I have already discussed. So let me write it down formally. One precisely requires this guy to be a well-defined function. In order for an aspect F to uphold the functional relationship between the two types X and Y. For every aspect F from X to Y between types X and Y of C. Okay? So let me illustrate this fact using the diagram or the Olog for a woman being a person. So let's try to understand the fact that the aspect is between these two types holds a functional relationship between these two types. How does it hold? A woman being a person we have to add this form of symbols. Is a valid aspect. Why? A valid aspect. That is I have to put it in patient. That is above is a valid aspect. Since so you read it as this. The I functor acting on this aspect is kind of function. We want this guy to behave like a function. Alright? So since I functor acting on the aspect is between the set of women, this is not the same as this box of woman. It is different from the set of women. So the I functor acting on this type gives me the set of women. Alright? So this I of the instant factor acting on the aspect should be a function between the set of women, the set of women to the set of persons. To the set of persons. Let us check if it is indeed a function. Okay? Is indeed a function. Why is it so? Why is it a function? can check immediately that two women, check two women can't be the same person. Right? And there is no woman in the domain of I is not there. No, I'm not insulting because I'm not saying that the domain of the aspect. I'm saying about the domain of this function. Instance functor acting on the aspect gives you a function. So it's valid to talk about the domain of this guy instead of the domain of this aspect. Domain. So aspect is an abstract morphism between objects of a category, which are types, but we are talking about function. So we have to take the aspect to the level of sets, and this is a function here in the category set, and we want it to satisfy all the properties of the function. And every member here in this set has an image here. In other words, and there is no woman in the domain of the map I is that is not a person. It's easy to check that. It is easy to check that this guy, I acting on is an injective function from the set of women to the set of persons. Okay? But it is not surjective. So I give it it's a very simple exercise for you to check that. It is not a surjective function. It is always an injective function. Okay? Alright, how much time are we left with?
26 minutes. 30 minutes.
Alright, so let me give you, I think we can postpone here, and in the next lecture video we'll shed some light on non-functional relationships and invalid aspects. Here we have seen that this is a valid aspect between two types because under the action of this instance functor, this behaves as a function between these two sets. So in the next lecture, we will start with an example of a non-functional relationship between two types, and then move on to another key feature of an Olog called facts. And then accordingly we'll complete the definition of the category of Olog as a category. Thank you very much for attending the third lecture. In the next lecture we'll start from here. We'll start from here.